Hi everyone, this video is the presentation of the solution to example 18 on rotated vessels. So this is the problem. A conical vessel with vertical axis has an altitude of 0.9 meter and is filled with water. Its base, which is 0.6 meter in diameter, is horizontal and uppermost. If the vessel is rotated about its vertical axis with a speed of 60 revolutions per minute, how much water in liters will remain in it? If the vessel is rotated about its vertical axis to such speed that the tangent to the surface at the rim is also the slanted height, how much water in liters will remain in it? Then if the vessel is rotated about another axis 0.6 meter from it, what must be the speed of rotation in RPM so that the water poured into it will be entirely discharged by the rotative effect? So for the first question, let's draw the figure first. These are the information. So substitute to solve for the height of the parabolic surface that will form. H1 equals 0.000558 times omega 60 square radius zero point 0.3 square. So H1 is 0.1811 meter, so it's very shallow. And from the figure, the volume that will remain is represented by volume of cone minus volume of paraboloid of revolution. So volume remained is quantity pi over 3 times radius of cone 0.3 square times height of cone 0.9 minus volume of paraboloid pi over 2 times 0.3 square times 0.1811. Then the entire two terms multiplied by 1000 to convert it to liters. So volume remained is 59.22 liters. And second, if the vessel is rotated about its vertical axis to such speed that the tangent to the surface at the rim is also the slanted height, so the slope of the surface here should be tangent of the angle that the slanted height makes with the horizontal. So tangent of theta is 0.9 over zero point 0.3 and that is 3. So this is the same also, that's tangent of theta is 3. Then tangent of theta is omega square in radians per second times distance x or zero point 0.3 over g. So tangent of theta, which is 3, is omega squared times 0 0.3 over g 9.81. So omega square is 98.1 radians square per second square. The formula for height of paraboloid is omega square r square over 2g, and we substitute the value of omega square. So h2 is 98.1 times 0 0.3 square over 2 times 9.81. So the height h2 is equal to 0.45 meter, which is half of 0.9. So volume remained is pi over 3, 0.3 square times 0.9, volume of cone minus volume of paraboloid pi over 2, 0.3 square times 0.45, then times quantity 1000. So volume remained is equal to 21.21 liters. For the last question, if the vessel is rotated about another axis 0.6 from it, this is the original axis, so we have another axis here, 0.6 meter rotated. What must be the speed of rotation in RPM so that the water poured into it will be entirely discharged by the rotative effect? So the surface should be tangent to the vertex with the same slope as the slanted height so that everything in the cone will be discharged, will be discharged by the rotative effect. So that's it. So it is obvious that when the tangent at the vertex is equal to the slope of the slanted height, everything here will be discharged. So tangent of theta, which is 3, is omega square times 0.6 this time because the distance from the axis of rotation to that vertical axis to the vertex is 0.6 divided by g 9.81. So 7.004 radian per second. Let's convert that to revolutions per minute by multiplying the factor 30 over pi. So we have omega is 66.88 RPM. So that's it for this problem.